All right, so here's the practice with electric current today. I've already done this, so I'm going to back this up and show you how to. Again, when you open it up, you have to start with a name. Now, to do the fundamentals, I'm going to do this part for you to give you an idea for this, and there's some learning that has to happen before you'll understand some of this stuff. So here you've got a basic circuit, and a circuit has to be a closed loop, so there's a path that these electrons can follow. And it says the diagram shows a circuit with a 3-cell battery, so 1, 2, 3 batteries, a light bulb, and 4 labeled locations, A, B, C, and D. Which statement describes the direction of the conventional current? So this is something we didn't talk about in the notes today. We're going to talk about it right now. Conventional current is what you use to think about the direction of the charge. So the charge in an actual circuit is negative and it's flowing through as a stream of electrons. Well, conventional current, as we talked about with Benjamin Franklin, was decided on arbitrarily a long time ago. And it's just the idea that one thing was positive and the other thing was negative. So conventional current, you have to imagine a bunch of positives flowing through the circuit. So the positives would be repelled by the positive end of the battery. And so in this picture, it's going counterclockwise like this. So it would actually go from D to C to B to A. That's conventional current. Now, in reality, years later, we figured out that it was the electron doing the moving, and we know that electrons are the opposite of protons. So electrons would actually be moving from this negative point up here clockwise, so through A, B, C, D. Conventional current is simpler because you follow the positive to negative route, and it was already set up by Benjamin Franklin. So rather than change it to moving electrons with negatives, we just keep conventional current because the idea is the same. Okay. Now it says the diagrams show a battery, a 3-cell battery and 2 light bulbs. All light bulbs are identical. The starbursts tell you how bright it is. So more lines around the circle means brighter than fewer lines. It says in which cases are the starbursts correctly drawn? Tap on the diagram to select. So one very simple thing about electricity, um, if it has only one loop like these circuits do, there's only one path to follow. That means that the same amount of electricity is going to go through every single point in that loop. So if these light bulbs are all identical, that means you got the same amount of current going through each light bulb. So it can't be this first one because this one's brighter and that wouldn't make sense. It can't be the second one because the second one's brighter and that wouldn't make sense. These light bulbs would be equal in brightness because there's the same current going through. Which of the following statements about electric current is correct? Current is calculated as the amount of energy a charge loses per unit time. Well, that's not what we define today. It is also not the amount of resistance. It is not the amount of distance. Current is calculated as the amount of charge, Q, that passes a certain point in time. So this is the one that you're looking for, the amount of charge divided by the time. Okay, now this is just a simple math relationship. It says the diagram shows a circuit with a 3-cell battery, 2 light bulbs, and 3 locations, A, B, and C. If 10 units of charge flow past point A in 20 seconds, then, so 10 divided by 20 is 1/2 or 0.5. So the next set of options here is talking about the amount of current in point C. Well, I already talked about this, but the current has got to be the same everywhere. So you're just looking for the numbers that will give you the same ratio, the same amount of current, which is 1/2. So 20 over 10 doesn't work. That's 2. 5 over 10, that is equal to 1/2, so that does work. This one would also be 2, and this one would be 1, so it can't be any of those. All right, almost done. The diagrams show a circuit with a 3-cell battery and 2 light bulbs. All the light bulbs are identical and arrow tails are shown next to the wires to indicate the relative current. More tails means a stronger current, and then the tip of the arrow indicates the direction. In which case are the arrow tails drawn correctly? Okay, well this one is showing you strong current, weaker current, even weaker current. That cannot be true because there's only one loop, so the current is the same everywhere. This one although it looks right because they're all the same strength, it's showing actual electron current, not conventional current, because if it was conventional current, remember it's positive particles, they wouldn't be repelled by this negative, so they wouldn't be going this way. It would be going clockwise, not counterclockwise, so we have to pick this one for conventional current. Last one. The diagram below shows to the right shows a circuit with a 3-cell battery, 2 light bulbs, and 3 locations. Which statement describes the relative amount of current at the 3 locations? Okay, so again, the current has to be the same everywhere. So anything talking about the current being different is not correct. So it's not the greatest at C. It's not the greatest at A. It is the same. Why? Because there's only one pathway to follow. Next time, we'll talk about some different types of circuits that can divide the current, and then you can have different amounts. But when there's one loop, the current is going to be the same everywhere. Okay, so now it's your turn to try levels 2 and 3.